By Chelsea Douglas, software engineer at Plotly, and we're going to be presenting interactive machine learning visualizations in Domino. So we're about to get started, and just wanted to let you know that if you guys are having trouble viewing the page, you may need to refresh it to view the webinar if you're still seeing the loading screen. So I just wanted to make sure you guys are seeing it. Okay, great. So today, Chelsea will be discussing how you can use Plotly's libraries within Domino notebooks to create data visualizations. So I'm going to pass the presenter setting to her, and she's going to kick it off.
Thanks, Adrian. So before we get started, I thought it might be a good idea to give you a bit of background information on both Domino and Plotly. So Domino Data Lab is an enterprise data science platform which makes data scientists more productive and helps teams collaborate better. It provides individuals with scalable compute resources and a centrally managed environment to work in. And teams get a central hub where all the work is saved and easily shared. And this results in faster progress for individuals and better results from teams. And so Plotly is a web-based data visualization platform for data scientists and engineers. And the engine behind our platform is Plotly.js, an open source charting library built on D3.js and StackGL. And we have APIs for R, Python, and MATLAB. And this makes it easier for data scientists to work in any programming language of their choice. And so today I'll be focusing on Plotly's Python and R APIs, and specifically using these tools inside Domino, which facilitates a really nice organized workflow. And this is especially applicable for group work or for projects that use multiple languages. Okay, so first we're going to look at Plotly's Python API. And if we check out the Domino app that I'm running here, I've already started 2 runs. So the first one we're going to look at is a Jupyter session. And I've started that just by selecting this notebook dropdown and Jupyter. So from here, if I open the session, it will open to this super familiar Jupyter page that Python users are probably familiar with. And I'm going to be looking today at Plotly's Python demo notebook. All right, and at the bottom here, I've added some styling. So I'm going to run that first so you can get some color in our notebook. All right. Okay, so we're going to be looking at a classifier comparison. And for this analysis, we're going to use a machine learning Python package called scikit. And a really wonderful thing about using Domino is that there are many really useful Python packages already installed. So all we have to do is import the functionality we need from NumPy and scikit. And that's what I'm just doing in this first cell here. And then now I'll import Plotly. And finally, I'll import OS, and I'm going to set my username and API key. And setting our username and API key is important for the plotting step, because this allows us to not only plot the chart we create in this IPython notebook, but it will also be saved online in our Plotly account. Okay, so the classifier comparison example that we're looking at can be found on scikit-learn.org. And that's basically the code in these first two cells here. And we'll be looking at and comparing multiple classifiers. And for a little bit of background information on that, classifiers are used to predict which class an observation would belong to given its characteristics. And we'll be looking at both probabilistic and non-probabilistic classifiers. And probabilistic classifiers can more specifically predict the probability distribution over a set of classes rather than just predicting the most likely class. So in this first cell, we're going to make the classifiers and also make the data sets. You can see what the functions make classifiers and then make data sets. All right, so after running that, basically we'll have the classifiers and data sets, and we can move on to the plotting step. All right, so the graph we're going to make today is, it's going to be a subplot, and we'll have a plot for each of the classifiers that we're looking at. And if we pop back up quickly to where we created the classifiers, you'll see we're looking at nearest neighbors, linear SVM, RBF SVM, decision tree, random forest, AdaBoost, naive Bayes, LDA, and QDA. So each of those is going to have a plot in the subplot, and we'll be looking at a scatter plot that's plotted on top of contours. So to do that, first we'll create some functions that will allow us to kind of run through and make scatter plots for each of those classifiers. So this first function here, make scatter, is doing just that. We'll make the scatter plot for each of the classifier. And this is a typical Plotly syntax where we're using our scatter function and setting the X and Y information, as well as markers because it's scatter. And while we're looping through here, this X-axis and Y-axis variable will allow us to set the plot number in the subplot. And then we're going to go ahead and do that exact same thing for the contour plots here. So we have the X, Y, and Z information, setting the color scale, and then also looping through. So we're setting the correct plot number as we loop through the classifiers. So now we'll move on to some stylistic code and kind of go through editing the axes. And a lot of this is self-explanatory, but we just want to kind of clean up the plots because it's going to be a very dense subplot. So we kind of want to hide some of the lines we don't need to see, such as the tick marks and the grid behind the contour plot. And then here we'll just set the ranges of each plot. All right, so then moving on to this cell, we're going to make the annotations. And so we'll be doing 2 annotations per subplot. So we'll be creating, we'll want to show the classification accuracy, and that will be displayed on the bottom right corner of each plot. And then we also want to add the title which will just be the classifier, so we can associate which classifier is in each plot. Okay, so this cell here sets up the figure, and it will set up the subplots in how many subplots we have in each figure, and then also organize the spacing between the plots. And then some final figure edits, such as the overall width and height of our plot. You'll see when we plot it, we made a very wide plot so we can kind of see all the classifiers compared to one another. And then also set the title here. All right, so now we're gonna just get to the fun part where we loop through all those definitions that I described above. And now just the final step of plotting. So we'll just use our pi.iplot function. And we should be able to see our plot displayed right in the notebook. Great, so now we can see our plots, and these are the training points in solid colors and the testing points in semi-transparent colors. And the lower right, as I mentioned above, shows the lower right number shows the classification accuracy on the test set. You can kind of see all of those. We have the name of the classifier up there, and you can kind of just scroll through because, as I mentioned, we have a pretty wide plot here. All right, so can zoom in a little bit and kind of see all of that. And at the end, we'll take questions, and if there was a part of the code you wanted to see a little larger or see anything more specifically, we can let you know. And head back to here. Great, so just to wrap up the Python information, all our Plotly graphs reside online in your online account, so that's pretty nice for organization. And also, if you want to create a static image, we have this image.saveAs function. So all we have to do is put in our figure variable from up here and set the file name, and we'll get this PNG image, which I then plotted in the notebook. Yep. So you can save and then also make sure everything's synced in your Domino app. And doing that, you can see one of the results from this notebook was this PNG file that I saved. And so now if I come back to my Domino app and go into files, we can notice that that PNG image was saved there, right here. And so now your group will have the chance to view it or download it. Great. So now let's take a look at running an R example. So if we go back to the runs page, we'll notice that, like the Jupyter session, I also started an RStudio session already. And I did that just by the same notebook drop-down menu and selecting RStudio. And when you open the session, it opens RStudio in the web browser, which I find incredibly cool and useful. And so Yep, basically over here you can see when you're in this Files tab, all the files that appear in my Domino app under Files also appear here. And I added an R script to my files, so we can open that up. Yep, and if you're familiar with R, you'll notice like just opens right up here and you can run through the code. Okay, so for this example, we'll be looking at Twitter data and a k-means clustering. And so we'll partition a given amount of observations into groups or clusters, and this partitioning is based on the cluster mean. So I needed a Plotly's library as well as this Twitter library to grab our Twitter data. And then we'll also use our color brewer to get some fun colors in the graph. Great, so you can kind of see the script that I ran through here, but I also have it saved as an HTML file so we can kind of see the code and the graphs all neatly put into one file. So if I pop back over to my Domino app and look at my files, I'll grab that HTML file and open it up. All right, so we'll take a look and kind of run through this file here. We could download it and open it, but I'm just going to show you in the Domino app. And let's see how we're doing on size there. Okay. Great, so as I mentioned, we'll just be visualizing this k-means cluster. And we'll just start looking at the code. I installed the libraries that I previously mentioned, and then we have this little app authentication, and that's going to allow us to get the Twitter data. So we used Plotly's Twitter handle, so we'll be looking at our Plotly's Twitter friends and followers in this example. Great. So if we hop down here to where we started doing the analysis and graphing, we just started with a preliminary graph. And so in our R API, we have this plot.ly _ly function, and from there you can just enter the data set that you're using, and then X and Y information, any styling information that you might have, and you can also pipe in a layout. And so this bit of code created this pretty simple graph. And so you might notice it's a little difficult to read, but a log transformation might help that. So the next step we took was just doing a log transform on the friends and followers data, and basically running those same functions again and getting a graph that's a bit more meaningful. So for the k-means clustering, we'll want to find the appropriate number of clusters. And we'll be using the elbow method to kind of see what the most appropriate number of clusters will be for our data, so we don't overfit. Great, so running through this, we found that the appropriate number of clusters was 7. I'm missing my elbow graph from here. Oh, here we go. So yeah, so when I'm going to zoom out a little bit so you can kind of see the entire graph here. Right, so basically when we're plotting the sum of squares, we'll kind of see where our curve starts to level out. And so we decided to choose 7 as the appropriate number of clusters. So now we'll fit the model using 7 clusters and use our color brewer palette here. And kind of make our final graph here using Plotly. So first we'll, as I mentioned before, adding the data set, the data we want to graph. We're going to hide the legend and add some color to each of our markers. And finally do some additional layout styling so we can make the background of the graph and the plot colored and set the grid coloring as well. So yep, basically we can see the Twitter friends and followers, Plotly's Twitter friends and followers in a k-means clustering down here. Cool, so this HTML file has a code and a bit of explanation about what we're doing in the code and then the graph. But sometimes you might want to get more to the point of just looking at the visualizations. So pull this over, whoops. So I have another HTML file here, which just includes the graphs. So this is a more simple dashboard, and you can see it's just the graphs that I just showed you. So this example is pretty interesting because some of our clients' data science teams use the same process to do their analysis in Domino, and then they use Plotly libraries to create the visualizations so you can get this interactivity and kind of see information about specific points. And then the visualizations are stored on the Plotly server and also rendered in this HTML back on Domino. And so our clients' business users then access these HTML pages, and they can use these as their business intelligence dashboards. And there are quite a few benefits from doing this because you get all of the power of Plotly without resorting to another BI tool. And Domino can actually schedule runs to automatically update the data to create the visualizations and save everything in order to recreate past results if someone wants to see how past visualizations were created or compare them to newer visualizations. Then you get a much tighter link between the analysis and the presentation layer than you would if you were trying to use more traditional BI approaches. So it's really, really useful, especially if you're if you do need to update these charts and keep clients and other team members updated to the most recent progression. Great. So I just want to mention you can you can fork this Domino app if you want to go through and see any of the, run any of the examples that I just showed you. And under the documentation, I've included links to Plotly's Python documentation and Plotly's R documentation. And there's many more examples in those docs, and it could be useful to run through some of those if you're interested in other types of visualizations. Okay, so I think we'll just open it up to some questions now. Yeah, so there's some questions about using Domino and Plotly together compared to other tools. And kind of going through and creating this presentation, a few other engineers worked on it with me, and it was pretty easy to keep everything stored and organized together. And as I mentioned earlier, Domino can schedule the runs. And when you're doing pretty consistent updates of your graphs, it's kind of nice to have that scheduler available. It kind of keeps the process automated in a really nice and efficient way. Yeah, so if you want to access the code, you can go to Domino and basically fork my project. And so I think you can see the URL here, app.dominodatalab.com/Chelsea/webinar-start. And yeah, if you go to that URL, you'll be able to see the presentation, and there's the option to fork it into your account, and then you can edit and kind of play around with it however you see fit. All right, so there's a question about the final graph in the clustering of the Twitter data. So I'll just pull that up again. Yeah, so basically, it was just a fun data set to look at, and we're kind of clustering in groups based on an individual's followers versus friends. So it's kind of the number of followers they have versus the number of people following them. And then that was grouped into different clusters. And so this cluster is based on the means. So yeah, you're just kind of looking at different groups of people that, and comparing if they have more people following them versus people they're following, or vice versa, and grouping based on the mean of that number. Oh, wait. Oh, yeah. Okay. Yeah, so we do have the option of streaming data in Plotly, and we have a few examples there that you can run in Python. So I'll just kind of grab that documentation and add it onto the README I have in the Domino app. Yeah, the RStudio browser integration is one of my favorite parts as well for that comment. And I think we'll kind of look for one more question. We do support the creation of dendrograms, so you can do that if you want. We have some documentation for that as well.
Yeah, that's
okay.
on Plotly.
Yeah, so I can pull that up for you, but I don't think we'll be able to actually run the example with the data we have right now because we're running close to the end of time here. Okay, let me add that in. And are there any final questions? Oh yeah, so the person that's getting a red error box trying to fork the project, you need to make sure that you're logged in with a Domino account. You should be able to see all the code without being logged in, but to run anything, you'll have to yeah, create an account so you're able to fork it into your account.
Good. So I think that's all the time we have. Love that. So I wanted to thank you all for turning out and joining our webinar. You'll be able to ask questions at community.plotly. You can also fork this notebook on Domino Data Lab's website. So dominodatalab.com, and you simply look for Chelsea's notebook there. So thank you very much.